Every day we learn new things about our place in the universe. We've discovered ways of looking at far-off places. From the first telescopes more than 400 years ago, we've learned how to see the universe in different ways. We look beyond what human eyes can see, observing radio waves, infrared radiation, and X-rays, as well as visible light. ESA is a partner in space telescopes like Hubble and Webb that help us answer questions about how the universe began and how stars and planets form. In space, we can see the sky in ways that would be impossible from the ground. At ESA's Space Astronomy Center in Spain, data from spacecraft is sent to the ground, catalogued and shared worldwide. By combining different observations, scientists can see how objects in the sky are changing and evolving. Sometimes data from old missions stored in ESA's data library can help answer new questions. ESA is also leading in new ways of observing the universe, such as by detecting gravitational waves. Every day we ask big questions about the universe and our place in it, and every day we look for new ways of answering those questions. At the heart of our solar system is the Sun, our nearest star and source of most of the energy on Earth. Living close to an active star can mean some unpredictability. The Sun's magnetic field causes what is known as space weather that can pose a risk to Earth and particularly the satellites we are using. ESA has sent Solar Orbiter to take the closest images of the Sun and also investigate the Sun's polar regions. ESA wants to understand more about the Sun and how its magnetic field is generated. The Sun has an 11-year cycle of magnetic activity, and changes in the magnetic field can cause solar flares and powerful coronal mass ejections. The Earth's own magnetic field can protect us quite a lot, but we can see charged particles from the Sun interacting with the atmosphere as auroras. ESA investigates our neighboring planets in the solar system to find out more about how they formed and whether any kind of life could exist there. Mars Express has been orbiting Mars since 2003 and was joined in 2016 by the ExoMars Trace Gas Orbiter. ESA also wants to land on Mars and bring back rock samples. Bepi Colombo was launched in 2018 to travel for 7 years to reach Mercury. With our partners in the Japan Aerospace Exploration Agency, we will find out more about the history of the planet and map its surface in different wavelengths. Finding the best route to fly around solar system needs a lot of planning since all of the planets are constantly on the move. Spacecraft can pick up speed or slow down by flying close to a planet for a gravity assist. So spacecraft launched from Earth sometimes return for such a flyby. Our mission to Jupiter's icy moons, JUICE, will be launched from Europe's spaceport in Kourou for a 7-year journey to visit Europa, Ganymede and Callisto to study how they were formed and whether they could support life. Every mission needs lots of new ideas to create sensors and instruments to answer scientific questions. One key question about the universe is how it all began. By looking at galaxies far away, we are seeing light that traveled a long time to reach us. We are looking into the past. Like Hubble before it, Webb will help us to look at objects as they were billions of years ago. We are also learning to look at the universe in new ways, such as through gravitational waves that form when black holes collide. A gravitational wave passes through everything it meets, including your body. They are so difficult to measure that the first one was only directly detected in the past decade. ESA's LISA mission will detect these waves in space and find out more about where they come from and the big events that cause them. Working with the Athena X-ray telescope, LISA will teach us more about black holes. Another big question about the universe revolves around dark matter. We can't see most of the universe at all, probably only about 5%. We can tell from its gravity that dark matter is there. The Euclid mission will map galaxies and the dark matter associated with them. It will also investigate what is called dark energy, which seems to account for 70% of the matter-energy mix in the universe. This mysterious force drives the acceleration of the expansion of the universe, with colleagues all over the world to find the most interesting questions about the universe and to think of new ways of answering them. In 1995, the first planet orbiting a star other than our Sun was discovered. Since then, hundreds of these extrasolar planets, or exoplanets, have been identified. ESA is working to understand more about exoplanets. We want to find out if they have atmospheres, and if they do, whether there are any signs in those atmospheres of chemicals linked with life. The Cheops mission is working to reveal the densities of exoplanets orbiting nearby stars. The future missions Plato and Ariel will find out even more. Plato will identify rocky exoplanets that might have liquid water, which is essential for life. Ariel will look at the atmospheres of exoplanets to find out more about how they form. The Webb telescope will also help to find exoplanets that orbit far away from their stars. We might be able to see if other solar systems have an equivalent of our ringed planet Saturn. Under the watchful eye of Mission Control at ESA's Space Operations Center in Germany, our spacecraft can work for many years collecting different kinds of information to send back to Earth. Some missions can keep operating for decades. Hubble is more than 30 years old. The instruments on some of our spacecraft need to operate at very low temperatures, and so mission duration is limited by the amount of coolant on board. In other cases, like Rosetta, the spacecraft eventually runs out of fuel and needs to be shut down safely. Once a spacecraft completes its mission, it's moved out of the way of future missions or allowed to fall out of orbit and be destroyed. But the data the spacecraft collect live a long life. Our archives support scientists around the world as they investigate all sorts of questions in astronomy and planetary science. Scientists can make new discoveries with archive data and by combining data from different missions.